Alright, let's run through this exam paper quickly. So here, nothing interesting. Give non-exact numerical answers correct to 3 significant figures or 1 decimal place for angles in degrees, unless a different level of accuracy is specified. Okay, 3 significant figures and 1 decimal place for an angle. For pi, we'll just use the pi on the calculator. Okay, first up we have the probability that Jane wins a game is 7 out of 10. What is the probability that she does not win a game? Okay, so the only options are she wins or she does not win. So to get the probability that she does not win, it's 1 minus the probability that she wins. And that's going to be 3 over 10. 3 over 10. So that's the probability that she does not win. Now Jane plays 50 times, plays this game 50 times. Find the number of times she is expected to win. So she's expected to win 7 out of every 10 times she plays. So 7 times the 50 games she plays, and that's going to give us 35 games. Okay, calculate this. So that's just going to be 0.4. We can just check that on the calculator. Let's do the calculator. That's going to be the fourth root of 0.04. So let's do 0.0256, the fourth root of that. Oops, got the bracket. That's 0.4, yes. Okay, so that's just 0.4, just something to do on the calculator. Okay, Emma has 15 mathematics questions to complete. The stem and leaf diagram shows the time in minutes it takes her to complete each question. Okay, so this is 3 minutes, 5 minutes, 6 minutes, 7 minutes, etc. 11 minutes, 12 minutes, 12 minutes, 13 minutes, and then 20 minutes. Okay? So the key to 0 is 20 minutes. Okay, yeah, so that means 20 minutes. Right? Complete the table. The mode. What is the mode? The mode is the most common number, or the number with the highest frequency. What is that? There are 2 7s, 2 8s, 2 12s, 3 16s. So it's going to be 16 is the most common amount of time. The median, that's the middle number. So here we have 15 questions. So we're going to say 15 plus 1 divided by 2 to get the position of the median. So that's going to give us 16 over 2, which gives us 8. So the 8th position. So 1, 2, 3, 4, 5, 6, 7, 8th position. So 8th position will be 11. Now we could have also gone and done this. So just cut everything from this side. So second last, third last, fourth last, fifth last, sixth last, seventh last, and the one that remains, the 11, will be our answer. So that is another way we could have done that. Okay. The range. So the range is just maximum minus the minimum. So that's going to be the biggest number is 20, the minimum, the smallest number is 3, so the range is going to be 17. Write down an expression for the range of k consecutive integers. Range of k consecutive integers. This is interesting. Probably many ways to write this. So I'm going to write it as k goes from negative infinity to positive infinity. None of them are included, where k is an element of the integers. Where k is an element of the integers. Pretty sure, I'm not sure if they want this though. So this is just saying you can go from the k, so this is actually just saying k is all integers. I'm not sure about this one. I don't think that's what they want. Let's think about this. For the range of k consecutive integers. K consecutive integers. We can say it like this. So it's from k minus a, or from it's from, we could say k is from a to b, where a and b are integers as well, where a and b are both integers. I'm not sure what they want here. This one, maybe we can check this one on the memo at some stage. I suppose there are quite a few ways to write it. They probably give them the simplest one, which I can't think of now. Okay, Hendrik draws a scatter diagram. Okay, put a ring around the one correct statement about this scatter diagram. Okay, it shows no correlation. We can't say that. It does look like it shows a correlation. Not possible to tell if there is a correlation, as there are not enough points. Maybe for that they probably have to tell you a minimum number of values to show that if there's a correlation or not. So I don't think we can say this one unless there's something specific in your syllabus that says shows a negative correlation. I think that's true. Shows a correlation like that, sort of, right? That's a negative correlation. I'm gonna circle this one. Pretty sure it shows a negative correlation. Not positive. Positive would go in that direction. That's a negative correlation. For B, each of the four scatter diagrams shows the same set of data. A line has been drawn on each diagram. Complete the statement. The line in diagram blank is the most appropriate line of best fit. So the line of best fit is the line that best fits the data in the direction that it goes, with the smallest gap on average between the line and the points. So that'll be this one here, diagram C. Diagram C, it's a nice line of fit, and the smallest average gap between each point and the line. Okay. Question 6. A rhombus has side length of 6.5 centimeters. It can be constructed by drawing two triangles. Using a ruler and compass only, construct the rhombus. Leave your construction arcs. Okay, so the diagonal has been drawn for us. So from the diagonal, we know the rhombus has to look something like that. That's how we draw this. Okay, so basically we know that each of these lines is going to be 6.5 centimeters long. So what we want to do is we want to measure 6.5 centimeters. Can I draw this over here? I'm not sure how to draw. I'm just going to say, okay, from here we measure 6.5 on our ruler and draw sort of a bit of a curve at 6.5 centimeters. And then from this side we also draw about 6.5 centimeters. Something like that. And then we just connect these lines. So that's going to be 6.5, that's going to be 6.5, that's going to be 6.5, and that's going to be 6.5 centimeters. And that will be your rhombus. Complete the statements, these statements. The reciprocal of 0.2 is. Okay, so for this, you'd probably first want to write 0.2 as a fraction. So that's going to be 2 over 10, which simplifies to 1 over 5. What's the reciprocal of 1 over 5? You just swap it around, so it becomes 5 over 1, which is just 5. Okay, prime number between 90 and 100. Okay, so let's think about 91. 91 could be 17 times 3, right? Not 17 or 3, 13 times 7 is what I meant. 13 times 7, yeah, that's equal to 91. So it's not 91. 92 is an even number, that doesn't work. 93, that could be 31 times 3, so that doesn't work. 94 even, 95 doesn't work, it can be divided by 5. 96 is even. 97 does work. Okay, so 97 is a prime number between 90 and 100. And then number B, from this list write down an irrational number. Okay, so any number that can be written as a fraction is rational, so it's definitely not the first one. 0.6 we can write as 3 over 5, that's not irrational. Square root of 7, that is definitely irrational. So as soon as you find any root, so the root of any number, and the answer just goes on forever, is not a whole number, then you know that's irrational. So that's irrational. 8 is obviously 8 over 1. Square root of 9 is 3 over 1. So all of these can be written as a fraction except for that one. So that is irrational. Okay, find B when A is. Okay, so first let's get B by itself. So let's multiply both sides by 5c, which gives us 5ac equals b squared, and then take the square root of both sides. So the square root of 5ac equals b. And then we'll substitute our values in. So b equals the square root of 5 times a, 625, times c. So that gives us the square root of 56.25, and the square root of 56.25 I believe is 7.5, I think. Let's quickly just confirm. So the square root of 56.25 is 7.5, correct. Okay, without using a calculator, work out 2/3 divided by 1/7/3. Okay, so we've got 2/3 divided by, let's change this into an improper fraction. 1 times 7 is 7, plus 3 is 10, so that's 10/7. So 2/3, then we can change this into a times and take the reciprocal of the second fraction. 7/10. Yeah, 7/10, that's right. Okay, then we can simplify this a little bit, make that a 5 and a 1. So we get 7/21. So that's going to be 7/21. Okay, write this in standard form. So that's going to be 6.54 times 10, and then we move the comma 1, 2, 3 spots. So to the power 3. But it's going to be -3. Because from here, -3 means we have to move it 1, 2, 3 spots, and then we'll get back to our original answer. That's -3. 6.54 times 10 to the power -3. Right, the number 1.467 times 10 to the 102 is written as an ordinary number. Write down the number of zeros that follow the digit 7. Okay, so we know we have to move the comma 102 spots to the right. So 1, 2, 3, and then if we move it again, we're starting with a 0. So the first 3 of these will not be zeros, so the next ones will be. So 102 minus 3, so the first 3 won't be zeros, and then whatever is left, that's going to be zeros. So it's going to be 99 zeros. Right, 0.04 recurring as a fraction in simplest form. Okay, so that's just going to be 4/99. Let's see how we get there. We can say let x equal the 0.04 recurring. Multiply by 100. So that's going to give us 100x equals, if we multiply this by 100, it's going to be 4.04 recurring. Now if we subtract the two, 100x minus x is 99x. And 4.04 recurring minus 0.04 recurring is just 4. And divide both sides by 99, which gives us x equals 4/99. So it's going to be 4/99. And we can always just confirm, check with the calculator. 4/99 gives us 0.04 recurring. Okay, question 12, we've got some sets here. The universal set is all the integers greater than 2. A is the prime numbers, B is the odd numbers, C is the square numbers. Describe the type of numbers in the set not B intersect with C. So not B is all the even all the numbers greater than 2 which are not odd. And intersect with C is square numbers. Okay. So it's all the square numbers that are not odd numbers. So all the square numbers that are not odd. So that's going to be greater than 2. Square number is not odd, it's like 4. Then 9 is not going to work, so then 16. And then 25 is not going to work, so then 36. 49 is not going to work, so then 64. So we can just say this is all the even square numbers. All the even square numbers. Okay. Complete the set labels on the Venn diagram. Okay, so now we have to use all of this to fill in here. Okay, so which set is completely contained within another set? Okay. So all the prime numbers, what is this overlap? Is there an overlap here? Okay, so let's assume so B is all the odd numbers, so B. So all the prime numbers are A. Okay, so the only prime number that's not odd is 2, but we're only working with integers greater than 2. So all the prime numbers in here will be odd numbers. And then this will be C, the square numbers. So there's a bit of an overlap between C and A, but no prime numbers or square numbers, so that makes sense. Okay, B, shade the region, not D, union with E intersection with F. Okay, so E intersection with F, so not intersection of E and F. So E and F is this part, so everything that's not that, union with everything that's not D. Okay, so when we've got the union, so we can first do everything that's not D. Okay, everything that's not D. Okay, so that's everything that's not D. And then we want to say all of this that's not D, union with everything that's not E and E intersection with F. So this is E intersection with F, so everything that's not this, part, we also have to shade. So there we're shading everything that's not E intersection with F. Okay, well, there we go. So only this part here. That's the magic part. That's the only part we're not shading. Okay, here they tell us A, B, and C are points on a circle with center O. DA and DC are tangents. DA and DC are tangents. Angle ADC is 44. Okay, that's given. Work out the value of X. Okay, so first we can say here, tangent and a radius make 90 degrees. Right? Tangent and a radius make 90 degrees. So that means we can find, so let's, if we want to write down all the rules, we can say angle DAO equals 90 degrees, and our reason for that is radius is perpendicular to tangent. Okay, we can do the same for DCO. DCO is 90 degrees, and our reason for that is again a radius is perpendicular to a tangent. And then we can find angle AOC, and that is going to be 44 plus 90 plus 90, so 360 minus all of these angles is going to be that. So that's going to be 136, and for that is angles in a quadrilateral. Angles in the quadrilateral add up to 360. Okay, and now once we have this, we know that X is half of that. So X, angle X, equals 136 divided by 2, which is 68 degrees. And the reason for that is angle at circumference equals 2 times angle at center. Okay, so X is 68 degrees. Question 14, okay, we've got a trapezium. The diagram shows the trapezium. The trapezium has one line of symmetry. Okay, so we know if it has this line of symmetry here, that's the only option we have, then that means that these two sides are the same angle, right? Because if we had a trapezium like that, then obviously this wouldn't be a line of symmetry, it wouldn't fit, right? So if this line is exactly the same as that one, same angle, then now it does have a line of symmetry. Okay, work out the area of the trapezium. Okay, so for this, let me construct here, straight down. Okay, so that means this is also 62 degrees. That's 18.2. This is also 18.2. This part here is 15.4. So we can find this length here, which is the same as this length here, by using trigonometry, right? So we can use tan. We can say tan of 62 is equal to the opposite divided by the adjacent. Let's call this y. Okay, so to get y, multiply both sides by y, and then divide both sides by tan 62. So y equals 18.2 divided by tan 62. That's going to give us the answer for y. So we've got 18.2 divided by tan 62. I'm just going to use all of this. We'll round off in the end. That's going to be the value for y. So then the whole bottom base, this whole area, let's call that a. So a equals 2y, which equals, take this and times it by 2. Whoa. So this, and then times it by 2. So that is our base A. Okay, so that's A. B, we're given at the top, that's 15.4. 15.4. Then the height h we know is 18.2. So the height is 18.2. So the area of a trapezium is half of the sum of the parallel sides, which is a and b, times the perpendicular height, which is h. Here we've got a half, and then a. So let's just do a couple of those digits: 19.354223312 plus 15.4 times 18.2. Okay, so let's just type all of that in the calculator. Okay, so we've got a half times 19.354223312 plus 15.4, and we times that by the height 18.2. So 316 point something something. So that's the area, and we want to round off 3 significant figures, so that's just going to be 316. Okay, complete the table. Let me just have a sip of water. Complete the table showing information about the congruence of pairs of triangles. First 2 rows have been completed for you. All diagrams are not to scale. Okay, so this one is congruent because angle, side, angle, angle, then side, then angle, which are the same, right? Angle, then a side, then an angle. Okay. This one is not congruent because sides are not in the same ratio. We've got 3.4, 3.4, we've got 3 and 3, but then we've got 4.8 and 4, so they're not the same, all of them. Okay, so here we've got a side, which is the same as that side, then an angle, which is the same as that angle, and then a side again, which is the same as that side. So this one is congruent. Congruent, and our reason for that is side, angle, side. Okay, here, so we've got, let's say, a 4.5 and a 4.5, then we've got a 5, so we've got a 5, then we've got a 4, then we've got a 4. So that's congruent, and that's because of side, side, side. Here we've got 5.2 and 5.2, then we've got a 35, and then we don't know what that is. So this one, if that's 65, this one's going to be 35. This one's 35, that one's going to be 65. Okay, so the hypotenuse is 55.2 in each case. We've got the right angle, which is the same, and then we've got another angle, which is also the same, 35. So this is going to be congruent, and that's going to be it's call it side angle angle. Right, 5.2 angle angle. 5.2 angle angle. That should be fine. Okay, A is the 0.57 and B is the 0.9, -1. Find the length. So length, this just comes from Pythagoras. So we can say the length AB is equal to the square root of the difference between the x values squared plus the difference between the y values squared. So that's going to give us 5 minus 4, -4 squared, which is 16. And this gives us 8 squared, which is 64. So that's going to give us square root of 80. And we don't want to just simplify this. They told us to give it to 3 significant figures. So we can do the square root of 80 and just write 3 significant figures. So that's going to be 8.94. So 8.94. Alright. Find the equation of the line AB. Okay, so we know it's going to be y equals mx plus c. To find the m value, the gradient, we can say that's the change in the y values divided by the change in the x values. So that is going to give us 8 over -4, which is -2. So far we know y equals -2x plus c. To find c, we can just substitute a value. So I'm going to substitute 5 and 7. So 7 equals -2 times 5 plus c. So that gives us 7 plus 10 equals c. So 17 is c. And that gives us a final equation of y equals -2x plus 17. Okay, find the gradient of the line that is perpendicular to this line. Okay, so let's first rearrange this line. So again, for perpendicular, let's maybe just go over the rules. If lines are perpendicular, the gradient of the one times the gradient of the other one is equal to -1. So if we rearrange this to get y by itself, then we get y equals 4 over 3x minus 5 over 3. So what is perpendicular to 4 over 3? Well, it's going to be -3/4. And that's probably just going to be the answer they're looking for, just -3/4. But we can also get that by using this formula and saying 4 over 3 for the one gradient times the gradient we're looking for must be equal to -1. And then we can just say -1 divided by 4 over 3. So -1 divided by 4 over 3 and gives us -3/4, -0.75. So -3/4, -3 over 4. Okay, here we've got some functions, f and g. Solve for f, g of x plus 1 equals gf of x. Okay, so let's do first f, g of x plus 1. Okay, so for this one, we have to put g of x plus 1 into f. So we could first do g of x plus 1 and then put that answer into f, or we could first put g into f and then substitute x plus 1. It doesn't really matter. I'm first going to do fg. So fg is going to be x squared minus 25, but instead of the x for f, we're going to put the whole function g, which is x plus 4. Okay. So then if g of x plus 1, yes, sorry. So if g of x plus 1, so now we replace the x with x plus 1. So we've got x plus 4 squared minus 25. But instead of the x, we're going to put, x plus 1. Plus 4 squared minus 25. So that's going to give us x plus 5 squared. So x plus 5 squared minus 25. Okay, that's fine. We don't need to expand right now. So they didn't tell us to do that, so that's fine. You can if you want to, but that's fg of x plus 1. Now we also need gf of x. Okay, so gf of x. So we're going to put f of x into g. So, okay, so let's do this. Gf of x. So now, in g, we had x plus 4. Now instead of the x, we're going to put the whole function f, and f is x squared minus 25. Okay, so simplify that. So x squared minus 25 plus 4 is minus 21. Now we need to set these two things equal to each other. So we're going to have x plus 5 squared minus 25 equal to x squared minus 21. Okay, let's multiply this out. So that's going to give us x squared plus 10x plus 25 minus 25 equals x squared minus 21. Let's get everything to one side equal to 0. So x squared minus x squared will cancel out. Here we've got 10x, and then that's all the x's. Okay, so then the numbers on the other side, negative 21, the 25 and the 25 cancels out. So we've got equal to negative 21. And then we've got x equals negative 21 over 10. Negative 21 over 10. Alright, let me just make sure I didn't make a mistake here. So fg of x plus 1 is going to be x plus 1 plus 4 is x plus 5. So x plus 5 squared minus 25, yes. That's going to be x squared plus 10x plus 25 minus 25, so just x squared plus 10x. This x squared minus 21, yeah. X squared minus 25 plus 4, x squared minus 20, yeah, all of that seems correct. 20 marks, 4 marks, okay. Question 19. Diagram shows a shape made from an equilateral triangle ABC and sector of a circle. Points B and C lie on the circle with a center A. The side length of the equilateral triangle is 12.4 centimeters. Okay, so that's 12.4, 12.4, 12.4. We've got the perimeter of the shape. Okay, so we've got this part. So all we need is this sector part here. So in an equilateral triangle, all these angles are 60, right? Because they have to be the same. So if this is 60, then this whole part is going to be 300. So we're working with a sector of 300. So for this perimeter, that's just so this arc length, sorry. Let's say arc length, just to recap what the formula for that is. Arc length is just a fraction of a full circle's perimeter. What fraction is it? Well, it's the angle over the full circle times 2 pi r. Because 2 pi r is the circumference of a circle, but it's just this fraction of the full circumference. So in our case, our fraction we want is 300 over 360. Over 360 times 2 times pi, and our radius is 12.4. 12.4. Okay, so 300 over 36, 360 is 30 over 36, which is 5 over 6. So that gives us 5 over 6 times 2, which is 10 over 6, which we can just simplify to 5 over 3. Okay, so 5 over 3 times pi times 12.4. 12.4, can we simplify this a little bit more? Divided by 3 is going to be 4. Okay, 60, and 0.4 times 5 is 2. That's 62 over 3 pi. Okay, 62 over 3 pi. And for our rounding off, let's just do that. I'm just going to check both answers to make sure I didn't make a mistake somewhere. 72 divided by 3 times pi. Where's pi? Okay, 64.9. So we get 64.9 from this calculation. And let's check from the start calculation. If we had 300 divided by 360 times 2 times pi times 12.4, 64.9, same thing, yes. Okay, so that's 64.9, correct to 3 significant figures. But that's not our final answer. Easy mistake to make, which I just did. We also have to add, so that just gives us this arc length, right? That's the arc length we calculated. So arc length plus the 12.4. So we have to add the 12.4, which will give us, so plus 12.4, 77.3. 77.3, correct to three significant figures. Number B. Okay, the diagram shows two sectors of a circle. The major sector is shaded. Okay, the major is the big one. Area of the major sector is 74.5. Let me just fill that in. 74.5. That's the area. Squared centimeters. And then calculate the radius of the circle. Okay, so again it's the same thing. The area of a sector is just some fraction of a full circle times pi radius squared, because that's the area of a circle. Okay, our case, our angle is 360 minus 41, which is 319. So 319 over 360 times pi times radius squared equals our area, which is 74.5. Okay, so we want to work out what r is. So we can say 74.5 just multiplied by 360 divided by 319 and also divided by pi, and that's going to be r squared. So r will just be the square root of that. That's going to be our radius. Okay, let's type all of that in. So we've got the square root of 74.5 times 360 over 319 pi. Is that it? Okay, the 16.3, correct to three significant figures. 16.3. Okay, and we can always just test that over here. So let's say if we have 319 over 360 times pi times what did we find for radius? 16.3. So 16.3 squared. Well, that's not going to be completely accurate because it's rounded off, but it should be close enough. See, that's a problem. 739. What did we do wrong here? Square root what if I do that? Okay. Yep, brackets are important. So 5.17. Okay, 5.17. Let's try that one. So that's why testing your answers might be useful. Okay, so let's try 5.17. So if we do 5.17, wait, that's it, 74.5 roughly if we round off. That makes sense. Okay, 5.17 centimeters. Expand and simplify. Okay, so it doesn't matter which ones you multiply first. I'm just going to multiply the first two first. So if we multiply these, we get 2x squared minus 4x plus 5x. So you can write all of that out. I'm just going to write plus x. And then minus 2 times 5 is minus 10. So all of that we still have to multiply by x plus 3. That gives us 2x cubed. Oops. 2x cubed. And then plus 6x squared. Plus x squared. Plus 3x. And then minus 10x. And minus 30. Okay, collect all the like terms. So the x cubed is only the 1. So 2x cubed. Then the x squared, 6x squared plus x squared is 7x squared. Then the x's, 3x minus 10x is negative 7x. And then minus 30. Okay, the force of attraction F newtons between two magnets is inversely proportional to the square of the distance d between the magnets. Find an expression. Okay, so if is inversely proportional to the square of the distance d. Okay, so that's for inverse. We've got k over. So these two things are proportional, and it's inversely proportional, so it's k over. And we can plug in these values to find the value for k. So 48 equals k over 1.5 squared. So then 48 times 1.5 squared equals k. Okay, 48 times 1.5 squared is 108. So k equals 108. So our formula then is f equals 108 over d squared. Okay, it's k over d squared, but k is 108. Now find the distance between the two, or when the distance between the two magnets is doubled, the new force is n times the original force. Work out the value of n. Okay. So when the distance is doubled, the new force is n times the original force. Okay. So we can probably the easiest just to use this that they already gave us, right? So, well, even easier is just to sort of know the answer from how squares work for inverse proportional, but we can just do doubling the force. So if we double the force, new force is n times, so the distance is doubled. Okay, so if we have f equals 108 over d squared, so if we double the distance, we're going to have 108 over 2d squared. Okay, so that's going to give us 108 over 4d squared, right? So how do we compare these two forces now? So we can say this one is equal to a quarter times the original one, times that, right? So we can see if that was the force, this is the new force. The new force can be written as a quarter times the original. So n is a quarter. So that's how I would have done it to show that. But also because we know we're dividing by the distance. So if you're dividing by the distance, then distance is twice, then twice squared will give us 4. So it's dividing by 4 basically. Okay, simplify this one. So everywhere you can factorize, you want to factorize if you can. So the top part we can factorize into 2x minus 4 plus 3. At the bottom we can take out a 3x as a common factor, and we're left with x minus 4, and these can cancel out, and we're just left with 2x plus 3 over 3x. Okay, find all the solutions of this. Okay, so first let's get set x by itself by dividing by 4, so we get that. Now let's find our reference angle. So our reference angle is going to be shift sin in calculator talk, otherwise just called arc sine. So shift sine of 3/4, and that is going to give us, let's see here, can we do this one? Arc sine, yes, of 3/4. It's going to be 48.6, 1 decimal place. So 48.6 degrees. Just make sure I wrote it down correctly. Okay, now we check. So sin was positive. This was a positive value. So sin is positive in this quadrant, 180 minus, and in the normal quadrant, right? So the normal quadrant and the 180 minus quadrant. So we have our x equals 48.6 degrees plus, and the period for sin is 360 degrees, so plus 360k, where k is an integer. That just says we can add or subtract 360 as many times as we want, so that's why it's an integer, right? It could be once, twice, negative once, negative twice, etc. So k can't be any real number. You don't want to subtract 360 half a time, but any number of times for 360. Okay, or, so that's this first quadrant here. Now for the second quadrant, x is 180 minus that. So what is 180 minus that? 180 minus, and let's just do 48.6. That's 131.4. So 131.4 degrees plus 360k, where k is an integer. Again, we're only looking for the values between 0 and 360. So let's start with this one. So 48.6, that's going to work. That is between 0 and 360. If we add 360, it becomes too big. If we subtract 360, it's too small. So that's everything done with that first one. Second one, 131.4, that's going to work. 131.4. If we add 360, it's too big. Subtract 360, it's too small. So that one is also done. Only those two values. Okay, solve. So we want to get a common denominator. Let's first factorize everywhere we can. So there's nowhere where we can factorize. So then we just find a common denominator, which is going to be x plus 1 and x plus 9. And I'm also going to just take the 1 over so long. Okay, so scratch that out, equals 0. So I just took the 1 over to become negative 1. So now, when they had this 1 here, that 1 only had the x plus 1, so it still needs the x plus 9. Plus 9, this 9 only had the x plus 9, so that still needs the x plus 1. Minus 1, this 1 had nothing, so it still needs both the x plus 1 and the x plus 9. Equals 0. Okay, so we can multiply both sides by the denominator. So if we multiply this side by the denominator, it goes away because it cancels out, and 0 times anything remains 0. So now we can just work with the top part here. So let's multiply in. So 1x plus 9, and then plus 9x plus 9, and then minus, and if we, okay, I'm just going to do all of this in one go, but you can first multiply these two brackets together and then multiply the negative here. So that's going to be negative x squared. Inside we would have had plus 10x, so now it's going to be minus 10x, and we would have had plus 9, so now it's going to be minus 9. Equals 0. Okay, let's collect our like terms. So we're going to have negative x squared. So that's all the x squareds. And all the x's, we've got 1x, 10x, minus 10x is nothing. And then we've got 9 plus 9 minus 9. So it's just going to be 9 equals 0. Okay, so then let's multiply by negative 1. So x squared minus 9 equals 0. Then we can factorize difference between two squares equals 0. So x equals negative 3 or x equals 3. Now from here you could have also just gone and said 9 equals x squared, and then take the square root, and remember plus or minus when you take the square root, 3. So both of those options are correct. So x is 3 or negative 3. Blank page. Okay, and that's it. Okay, I hope you found this a little bit useful. Let me know if there's any one of the questions that you need some more explanation on. Otherwise, yeah, I hope this was good.